are getting started.
Hello and welcome to the Learning Unit, Manual Material Handling, which is part of Advanced Ergonomics. My name is Teresa Stack. I'm an assistant professor with Montana Tech of the University of Montana, and I'll be providing the lecture content for you. Our training objectives for today are to help you understand the factors which affect manual materials handling, as well as be able to relate back to the physical workplace risk factors and how they can be reduced or eliminated to prevent injuries or illnesses in the workplace, and also help you become familiar with typical manual material handling issues as well as some solutions that are out there. So there's lots of different kinds of suggestions throughout this particular learning unit. You may find it beneficial to download and either follow along with or reference later the manual materials handling checklist form, which can be found on Moodle under this learning unit. So as common, what types of injuries do we find during our manual materials handling tasks? And spinal injuries are, of course, the most common, with the most common body part being the back. The most common cause is overexertion. In 2012, musculoskeletal disorders accounted for 34% of all injuries and illness cases recorded by the Bureau of Labor and Statistics. The most recent dollar values that I was able to find were $19,000 for a lower back injury and $13,000 for an upper back injury. As you can see from my husband's hospital bill, which was $96,000 in 2008, I think that these may be somewhat misrepresentative. My husband's hospital bill was only for his stay there and the surgery, and it didn't take into account post-physicians, healthcare providers that he's seen, as well as, of course, the pre-healthcare providers that he's seen and medications that he was on. Other types of injuries associated with manual material handling are crushing, caught in and caught between, hands, fingers, feet, and toes, as well as slip, trips, and fall injuries. Manual materials handling is present in every industry, from academia to healthcare workers to oil rigs and construction. So if stuff goes in and stuff goes out, there's some form of manual materials handling. We usually categorize it by its form: lifting, lowering, pushing, pulling, holding, or carrying. And as are most of our solutions that we put into place, whether it's safety, health, industrial hygiene, or ergonomics, education is certainly the key to injury prevention, having people aware of what their hazards are in the workplace. So some training topics that you may consider in your work site would be to recognize the specific physical workplace risk factors that are associated with that task or trade, and outline them for your staff, as well as define what the contributing workplace risk factors are, whether they are personal or found in the workplace, and how they can contribute to but do not cause a work-related musculoskeletal disorder. It is certainly important to know what the signs and symptoms are of work-related musculoskeletal disorders, more specifically that any pain or discomfort that doesn't go away after rest, so after you sleep at night, is not relieved by rest over the weekend or interferes with your after-work activities. It's probably an indication that something needs to be changed in the workplace, or over time a permanent disability can be predominant and develop. So our example here is our Child Development Center workers who are encouraging children to climb the stairs instead of always picking them up. Maybe we can reduce their exposure to heavy lifting and awkward postures if they can encourage the children to walk up the steps instead of having to lift them all the time. Really, nurses and orderlies laborers, construction groups, and child development center workers have a fairly high rate of spinal or overexertion injuries. So what type of administrative controls can we put into place for manual materials handling? One of the simplest ones is simply to alternate your heavy tasks with your light tasks. Perform your heavy tasks in the morning when workers are fresh and the temperatures are cool, or spread your heavy tasks out throughout the day so that they can alternate with some light tasks. Can you provide a variety of jobs to eliminate the overuse of any one muscle group, or rotate workers through different jobs, which again prevents the overuse of one particular muscle group or body part and helps workers to change their posture? Modifying the workplace so that workers perform within their power zone is an engineering control and not an administrative control. And then there's team lifting versus lifting teams. So team lifting is when you get two people together and they perform a lift. They may or may not have worked with each other performing that lift before in the past. If you're going to implement an administrative control such as team lifting, it's much more efficient and effective to have a lifting team. A lifting team is a group of individuals who are trained to work together, and they are matched by strength and height. They know the cues for lifting and lowering, and they're less likely to be injured when working together. So when should we think about implementing a manual materials handling solution? And you can see from the manual materials handling tool, which you have found on the Moodle checklist, as well as the background information which you learned from going through not only the NIOSH lifting equation, but the ACGIH-TLV lifting tool and the mill standard, is that anytime somebody's lifting more than 30 pounds from a standing position, 10 pounds from a seated position, lifting with their hands above their shoulders, their arms at or below knee length, or held greater than 12 inches from their body, the task can probably benefit from some type of manual materials handling solution. And now, after going through biomechanics and the lifting assessment tools, it makes sense where these numbers came from. That high-frequency tasks, such as those that are done at 6 lifts a minute, where we chose Table 3 from the ACGIH-TLV, 30 to 35 pounds is the maximum weight that somebody can lift safely. We know from workstation design that nobody should ever be lifting more than 10 pounds from a seated position. So this goes through some basic steps to help you visualize what a better or proper lifting posture would be. And you can see in pictures 1 through 3 on the top that he's actually performing this lift in 2 steps. So first, grabbing onto the brick and then pulling it close into the body. So in picture 1, ears are not over the shoulders. In picture 2 and 3, ears are more closely over the shoulders and shoulders over the hips. Then you can use that one leg which is up in the air, so this person did not go down into a full squat, but a one-legged squat. And you can use that leg that's still elevated to help push yourself back up into the upright posture. So from our lifting assessment tools, this enables the person to hold that load close to their body to relieve the stress on the lower back and reduce that lever arm, as well as keep their posture more upright instead of being in a bent posture where your ears are not over your shoulders. Some folks really have a hard time lifting in the squat position because it's their knees and ankles which may hurt them as opposed to their back, as well as when you squat down to pick something up, if it's directly in front of your body, then your knees get in the way of your hands, which pushes that box or that item even further away from the person. So the one-legged lift is a way to get a little bit closer to your task and use that standing leg to get back up again. It also helps enable balance. So these are 2 really good examples of team lifting or lifting teams, where we have people who are equally matched by height, and hopefully the weight is equally distributed between the two workers. Lifting tables are really great pieces of equipment. They have a scissoring mechanism on that lowers and lifts, and they basically bring the worker to the height. They basically bring the work to the height of the worker, hopefully they're to elbow height. So you can see in the first picture, the scissor lift table that is green. This also orients the work towards the worker, so the worker doesn't have to change their posture or bend down to be able to see the work. The upper picture on the right shows a Lazy Susan top, which rotates 360 degrees. This is really good for packing operations, shrink wrapping operations, or inspection. And the pallet jack that also elevates to the height of the table. This is a wonderful piece of equipment. In lots of warehouses or in your shipping and receiving area, items come in on pallets, and they're usually just stored on the floor, and that's where people do their check-in, or they uncrate the pallet and then take the boxes one by one and put them on the check-in table. This not only eliminates a step, kind of that lean engineering, getting the waste out of the system, but also brings things into their working height. So we're looking again a lot at ways to improve people's posture. Another use of a scissor lift table in the first picture, the worker has to deviate their posture to be able to see the pump that they're working on, versus take the air conditioning unit, put it on a scissor lift table. Apparently you have a nice place for your coffee cup there, but the scissor lift table can elevate for the standing posture, lower for the seated posture, or anywhere in between given the stature of the individual who's doing the work. What's really neat about having these particular scissor lift tables, if you're able to put enough of them in your work site, or you have the type of work site that allows for an industrial type process through setup, is that you can have a scissor lift table for every piece of that the workers are working on, and then that scissor lift table stays with the workers throughout the entire process. And it also goes to kind of that lean engineering solution where you're not taking the widget that you're working on and off of a workbench or a platform repeatedly. So another example of use of a manual materials handling solution, this is the example on the left is a worker is holding a 550-pound piece of wood. It's called a keel block, and you cut it at a certain angle and then wedge it on both sides of the submarine, so when you drain the water and you have your submarine in dry dock, it basically doesn't roll over. And so the problems that they had when they were doing these cuts is the weight of the block is quite heavy, and it would take a long time to push it through the band saw. So they recommended, or they requested a scissor lift table that has a roller transfer ball top on it, so it's like a conveyor. They use a platform truck, then they bring the scissor lift table down to the same height as the platform truck. They're able to push the keel block from the platform truck onto the roller transfer table, raise it up to the height of the scissor lift table, and now push it through the bandsaw without having to support that weight. They're able to do more true cuts, as in increase their accuracy, and then when they got so far forward that they were reaching across the scissor lift table, they use a push stick to push it the rest of the way through. As much as possible, whether it's the cheap solution, such as stacking pallets on top of each other, or the more expensive solution, the one in the middle, which is a scissor lift table with an accordion skirt on it, you want to bring the work up to the worker so they're not bending forward. Remember, the power zone is knuckles to shoulders, and that's where we are not only our strongest, but we're able to maintain those postures from longer periods of time without having undue postural stress. So some easier ways to lower, again, a scissor lift table brought up to the height of the items that we're moving, that we're handling. So now we can just slide it. We use gravity or using the edge of a bucket to do your decanting work. Another example, not as favorable, but you can use a fork truck to bring the pallet up to the elbow height, as well as smaller decanters so that you can fill smaller bottles instead of a large bottle. You can bring the work to the worker, but you can't make them open the door. So unfortunately in this picture, these are exactly the same transportation crates. They were used to bring components or aircraft parts over to the area in which the aircraft was being repaired. And in the first picture, the worker doesn't recognize or take the time to fold down the door. When you fold down the door, it brings the worker closer to their job, and therefore they're putting less stress on their lower back. Basically, they're able to reach the bottom of the bin without having to bend forward quite so severely. So some elevating platform carts, instead of pushing from the bottom like a scissor lift table, these have springs on them, and they're able to, again, allow your load and your unload height to always stay even. This is a cutaway of a laundry cart and works really well for bringing that laundry up as you're unloading it, as well as bringing the workpiece down when you're loading. And we know that sometimes you just have to get more people to do the job. There's no typical day for a CB. These folks that erect our buildings, build bridges and roads out in places without much power in some makeshift areas, have learned lots of great skills such as building in place or building close to the work zone. Here's a great example of where the same group of workers, these CBs, are using round stock to be able to move the bridge abutment instead of waiting for the fork truck, which could have taken a long time to get there. So yes, they're doing lots of manual materials handling, but they didn't get 10 guys to pick it up. Instead, they got 2 and 3 pieces of round stock, right? So how do you get a grip? So there's some examples here of a handler for the agricultural area where you're working with buckets, as well as a handle that can be used to maneuver or handle flat stock such as sheet metal or plywood or drywall. And these are really cool attachments so that you can create a better contact point. Many times in manual materials handling as well as in lifting tasks, the limiter, as in the thing or the item or the compression, truly it's the compression, that challenges people in carrying or lifting is how comfortable it is in their hands. So this piece of plywood is not too heavy for this gentleman to carry, but it's quite awkward and causes a whole bunch of compression. So I have an example here. And so what you don't see is the posture, or is what this person's picking up. So he's inside of a very small aircraft. They're about as big as the CRJ-200s, which are the types of aircraft that have 12 to 20 seats going forward to aft and 4 seats across. Very small aircraft, but this one's filled with electronic equipment. And they have to pick up this 240-pound amplifier and pass it through the really small door. And the amplifier is only 1 to 2 inches shorter and narrower than the size of the door. The problem with, or one of the other challenges besides the amplifier being about the same size of the door, is that you can't tip it sideways when you're moving it out of the aircraft. So in our first picture, you can see the circle of the amplifier. It's got some really difficult contact points for gripping onto. You can't tip it because it has a stabilizing solution in it that helps to mitigate the effects of cold and hot weather. And now you can see the door, how small and narrow the door is, plus those stairs are quite steep. And there's really very little room in the alleyway here. And this is the posture that the individual is in when he's trying to pass that amplifier forward throughout the door. And so now if you take a moment and you select this hyperlink or you watch it later, you can take a look at a really cool solution that we recommended for these folks. And it helps to distribute the weight from shoulders through the spine instead of just canting the body forward and putting all that lever force on the lower back. So it helps distribute it in a larger area. So take a look at the video. It's kind of fun. So some other ways to get a grip if things are heavy to hold on to. Is there a way to put two handles on it? I saw a situation over at Puget Sound Shipyard where workers were using a Sawzall, which is a tool which has a reciprocating blade on it. It moves back and forth, and you could basically cut through just about anything with the Sawzall. They were using them above their heads, and so they just put two handles on it to make it easier for people to not only support that weight, to maneuver it. The picture on the bottom shows a grate that is over the hopper. So when they're filling the hopper with media that they would use for blasting, they're able to cut the bag open and shake it through the grate instead of holding the bag and shaking it that way. So it reduces a lot of hand forces that way. Some other ways to alleviate the compression and increase your friction are by having appropriate gloves for people to wear that increase that friction, makes it easier for them to hold on to, as well as folks that are doing a lot of lifting where they're putting items up on their shoulders. You can put a pad there, and that helps to decrease compression. Now, for all you safety folks, do you see which one of these tasks is slightly hazardous because it can become a projectile? We'll see in hand tools that the appropriate diameter for a male and a female's hand is between 1.5 to 2 inches, and that is basically the size of the handle that people are holding on to. So increasing the diameter of the handle makes it much more comfortable for this person to carry the load, as well as the picture on the bottom. What we had here is this was a power con. It is used for welding tasks, and the workers had to carry it up some pretty steep stairs, as well as carry it down a long length. So they had to carry it from the dock down through the pier. And so a supervisor came up with this really cool idea of just basically putting a handle on it, so kind of taking a spreader bar and putting it on top of the power con. He created the handle so you can use it with all different types of power cons. And our really quick return on investment ratio there, now this was in 2002, the average cost of a back injury was $15,590. We divided that by the cost to make 12 of these, which is $1,800, and our payback ratio is 8.6 to 1. So another way to present this back to the management would be for every buck that you spend on this project, if we avert one back injury in a year, you make back $8.60. I'm pretty sure all of us would like to get an 8.6% payback ratio back on every dollar that we put into our 401k plans. So easier ways to move and carry, we have our typical drum dolly. But recognize that for some shorter workers, it can be quite challenging to use. As you can see how high he has to lift his foot to be able to cant that drum dolly back when you have drums on it, which can be quite heavy. The picture on the top is a fork truck attachment. And then the picture on the right, which I really like a lot, this is called a drum raptor. What's really cool with this is it not only goes up and down, but it has a really wide wheelbase, so you can put it up to the scale and drop the drums right onto the scale. It also rotates about 180 degrees, so you can use it to decant products. So here again is another video that I need to upload onto Moodle, which I'll do for you, so you can take a look at these cart tuggers. They're pretty cool because they are electric, so we only have to charge them up. We don't have to worry about any gas in our workspaces. We have implemented them in hospitals for moving gurneys around for bariatric patients, as well as in a hospital where we've moved a chart cart around, which is a big cart full of medical records. In repair operations, when they're repairing some helicopter catching equipment that they use on the decks of aircraft carriers, as well as large engines, moving them around shops. Also use them in mail rooms. The picture that you see here is a tugger that was used to move a storage rack full of tires around the different shops. If you live in a bigger city, you may have seen them at your Walmart or your airport. So our flexible conveyor came from the very first presentation on the basics of ergonomics. You can see how you can expand it out, and you can actually cant it, as in have one side up higher than the other, so you can use gravity to kind of push those to help gravity move the boxes or the components from one spot to another. There are motorized platform trucks when people are moving stuff over long distances. If you're even considering one, I'm sure there's a lean engineering solution that you couldn't put into place, since this is wasted time over the transportation, the amount of space that people have to go from point A to point B. If we can move the components and the parts, whatever it is they need to bring into the work zone closer together, we've just saved time. And of course, time is money. So there's another video here for you to watch. So another example, we're kind of coming up in our dollar values here. So these are more expensive. They're close to $125,000 to $250,000, and it's a vertical storage unit. And what you see in the first picture is the gentleman is showing you the round stock, which is extraordinarily heavy, between 90 and 125 pounds apiece. And if he has to get a piece of round stock out that's at the bottom, he has to move all these other pieces out of the way. So the solution that we put into place is really similar to this solution here, where you have all these different carousels, so it's almost like a child's merry-go-round. The carousels are stacked one above the other. On the control panel, you tell the carousel which one you want to deliver to you. It delivers to you at elbow height, opens up, and then you have the pieces and the parts right at elbow height. We've used them for medical records, for medical supplies, round stock, angle iron. The picture you see here is the first sheet metal storage unit that was ever installed in the United States. What else is really neat about these particular vertical storage units is that it takes advantage of all your vertical space. The software that comes with them provides excellent inventory control, so you don't have wasted time and people taking inventory. You can have it coded so you know who takes what, as well as certain carousels locked out so people can't take certain pieces of equipment or parts or components if you need a clearance or a pass to be able to take them. Really, really cool storage units. So we really don't want people in manual materials handling situations to walk up ladders, carrying boxes to put them on higher shelves. You know that you don't have 3 points of contact, plus the box itself can cause you to lose your balance, and it blocks your view. And there's lots of different aisle crawlers that can be used, whether they're controlled from the platform in which the worker stands on or controlled from another platform. So in most of our material handling gadgets, pieces of equipment, they come with wheels. And typically a harder caster decreases the push forces. So it's nice to have a hard plastic caster versus a filled up with air pneumatic caster. Pushing and pulling forces are lowest on your harder mediums such as concrete, and then they increase as you go to mediums that become softer, tile, asphalt, and carpet. As the diameter, that's the size of the wheel, increases, the push forces are decreased. So an example is if you have a cart that's really difficult or challenging to move, people can't quite get it moving, or they're moving it not only on tile and on carpet. If you can increase, put a bigger tire on it, you can decrease the push forces. Research in this particular area has also showed that increasing the width of the tire, going to a wide body tire versus a narrow body tire, doesn't do anything for the push and pull forces. And of course, timely maintenance. As you can see here, the last time this caster was changed out is 1968. It is currently 46 years old and can probably use a little bit of maintenance. They don't last forever. And there are, I can't tell you how many different kinds of casters out there. Ones for dirty environment, sealed ball bearings, ones that don't have any lubrication in them at all, or can be used in bake ovens where the temperatures get extraordinarily hot. So you can almost always find a wheel to do the job for you. So for man and materials handling, we want to try to minimize our travel distance. And that's how far somebody is lifting, lowering, pushing, or pulling, as well as decanting, pouring something off. Can we minimize our travel distance when we're carrying and transporting stuff? Anytime you draw your diagram out from point A to point B, if two lines cross one over the other, it probably can benefit from a lean engineering solution. Are your work cells a circle or a U? It's much more efficient than having crisscrosses all over the place. Can you change your container? Can you decrease the dead weight, put whatever it is that you're carrying in a lighter container, and change the characteristics for which the hand comes in contact with the container? Are there cutouts? Can we get the load close to the body? Or can we maybe increase the dead weight? That's instead of getting bags of flour in 50-pound bags, let's get them in 500-pound boxes, and therefore there's no way for the person to pick it up without the use of a manual materials handling aid. So please go through, take a look at the checklist, watch your videos, and I hope you have a splendid day.